Welcome everybody to Algebra 2, Section 8.4, Evaluating Inverse Trig Functions. So the warm-ups, name the reference angle and then find the exact value of the following four. So the sine of 30 degrees, it is actually its own reference angle because if you recall, reference angle we want to get on our coordinate plane as close to the x-axis as possible. So we said, hey, think of the bow tie and said, okay, so for degrees, you want to get as close to 0 degrees or 180 degrees as possible, and 0/360 degrees. For radian, it would be 0 and 2 pi, and pi is what you want to get closest to. So sine of 30 degrees, well, 30 degrees is already as close to it you can get for 0 to 180. So the value of sine of 30 degrees is 1/2. On B, cosine of 2 pi over 3, the reference angle, you can get closer to the closest route to the x-axis, or 0 or 2 pi or pi, would be pi over 3. So the reference angle is pi over 3, and I'm going to actually put it as equal to that. And then cosine of 2 pi over 3, or cosine of pi over 3, and then you make it negative because that would be in the quadrant 4. And that would be, or excuse me, quadrant 3. And that would be negative 1 over 2. Sine of 7 pi over 4. I'm sorry, 2 pi over 3. That would have been in quadrant 2. I misspoke 3 times there. Anyway, C, sine of 7 pi over 4. The reference angle here, the closest route to either 0/2 pi or pi, would be pi over 4, because it's pi over 4 away from 2 pi. Now the actual value of sine of 7 pi over 4 is the same as the sine of pi over 4, but you make it negative because that's in quadrant 4. So you have negative square root of 2 over 2. Because remember, any of the pi over 4s, sine and cosine are always square root of 2 over 2. And cosine of 7 pi over 6, the reference angle is going to be pi over 6, because it's pi over 6 away from pi itself. And cosine of 7 pi over 6 would be the same as cosine of pi over 6, except for it would be negative, because that's in quadrant 3. And cosine's negative in quadrants 2 and 3. So you end up getting negative square root 3 over 2. Next, on the second problems, where there's A, B, and C, we're supposed to find the decimal approximation of the following, so type it into your calculator and round to the nearest hundredth. That is 2 decimal places. So tangent of 2.6 is 0.45. And I would suggest doing B and C on your own and then seeing what you get. Notice though, on B, you'd make sure, just like on A, you're in degrees, whereas on C, you have to make sure that you're in radian. So cosine of negative 34.2 degrees is 0.83. And sine of 3 pi over 7, once again, you need to be in radian for this, is 0.97. Next, we're going to talk about the inverse of sine and cosine today. So what makes the inverse of a function itself? So so every function has an inverse, but not all the inverses are functions. So if you recall, for anything to be a function, the domain doesn't repeat. I don't know why I did a capital D there. Another way to know is that it passes the vertical line test. Meaning if you have a graph and you draw vertical lines through it, it hits no more than 1 point. Any vertical line does. Now, inverse sine function. We actually talked about this a little bit in geometry. And we write it like this. Y would be equal to inverse sine of x. And what that's saying is, and by the way, you don't necessarily need those parentheses. That negative 1 is not an exponent of negative 1, so it's not saying 1 over sine. Rather, it's just our way of writing it. That's the inverse. Now you could also write it like this. Y equals arc sine of x. Arc sine and inverse sine are the same thing. They're just two different ways to say the same thing. So heads up, if you ever see one or the other, they're just the same. Very interchangeable terms. Principal values of trig functions, aka restrictions on inverse trig functions. So inverse sine is only a function on a certain domain. Okay, so only certain x values left and right is it a function, because at other points it would not pass the vertical line test. And the same thing is true for inverse cosine and inverse tangent. So for example, inverse sine, you can go between inverse sine and sine just fine if x is greater than or equal to negative pi over 2 and less than or equal to pi over 2. And on a picture that would look like this on the graph. And that's the same thing as saying negative 90 degrees to 90 degrees, or 270 degrees to 90 degrees really. But you just can't go all the way around there. And so here obviously it'd be positive and here it'd be negative. And maybe that's not obvious, but the reason to be positive up here is because the y values are positive and it'd be negative over here because the y values are negative. And when we had our unit circle, remember it went cosine comma sine, and sine acted as the positive. Now the domain of inverse cosine would have to be 0 is less than or equal to x, which is less than or equal to pi, which is the same thing as saying anywhere between 0 degrees and 180 degrees. So that would be anywhere from here to there. So anywhere higher than the x-axis, anywhere above the x-axis. And it's positive in quadrant 1 and negative in quadrant 2, just like cosine itself would be, because cosine was our x values on our unit circle. Inverse tangent, the domain of that, is going to be negative pi over 2 is less than or equal to x is less than or equal to pi over 2. The same as inverse sine, which once again would be the same as negative 90 degrees is less than or equal to x, which is less than or equal to 90 degrees. So that would look identical as far as the possible values it could be and when it's positive and negative compared to sine. Now some useful inequalities are that cosine of theta must be between negative 1 and 1, including negative 1 and 1. It could be those values. And sine of theta must also be between negative 1 and 1. Now we're going to practice evaluating an expression. So finding out, kind of like above here, hey, what sine of 30 degrees, cosine of 2 pi over 3, stuff like that. And we're going to use inverse sine and inverse cosine, inverse tangent in that as well. So some two little tips here, 2 steps for this is one, find the reference angle. That's what we were talking about earlier in our warmups as well. It was noting the reference angle. And then once you find the reference angle, and you figure out, oh, okay, so for the reference angle of 30 degrees, sine would be 1/2, for example. And then from there, you find the angle in the correct quadrant. It says use the bow tie to do this, or think of the bow tie to do this. That's this little thing again of saying, hey, just remember which quadrant we're in, and we're saying, hey, all students take classes to remember which function is positive in which quadrant. So remember that they are all positive in quadrant 1, sine is positive in quadrant 2, tangent is positive in quadrant 3, and cosine is positive in quadrant 4. So if you can remember those things, as well as your few main spots, they're 30 degrees, 60 degrees, or 30 degrees, 45 degrees, and 60 degrees, as far as which one's which for cosine and sine. remember x and y in the unit circle are cosine and sine respectively, then you can remember the entire unit circle. So here, we're going to do these without calculators, and they can be in both radians and degrees. So that means the pi over whatever, and this many degrees as well. We're more familiar with degrees. So when you have the inverse sine of negative 1/2, that means, hey, your value of sine gave you negative 1/2 sine of some angle. So we're trying to figure out what was the angle. So what that's saying is that's equal to some y or some theta. And so what we'd have to do then is you have to take the sine of both sides. And what happens is inverse sine and sine undo each other. They cancel out, similar to how like a square root and a square undo each other. And we get negative 1/2 is equal to some sine of y. Now what we have to figure out is what y or what theta or what angle would the sine of that give us negative 1/2. And we must remember that it has to exist, because for us to have inverse sine and sine, we said it had to be between negative pi over 2 and pi over 2, aka negative 90 degrees and 90 degrees. We said that earlier in that little box on the previous page of notes. And so it would be negative 30 degrees. Because typically 30 degrees would be one sine of 30 degrees to me is 1/2 in general. Sine of 30 degrees is 1/2. But because it's negative, we have our 4 quadrants, and sine is negative in quadrants 3 and 4. Well, if it must be between 90 degrees and negative 90 degrees, as we talked about on our previous page, inverse sine only exists between quadrants 1 and 4, and we said sine is negative in quadrants 3 and 4, it must be quadrant 4. So that makes it negative 30 degrees for our answer then, to make it in quadrant 4, aka negative pi over 6. So once again, how we did that is we said, hey, if you have the inverse sine of something, you're really asking, okay, the sine of what angle would give you that number, or that value? And so we said, okay, well, sine of 30 degrees is 1/2. So, or sine is 1/2 when we're taking the angle of when we have the angle of 30 degrees on our unit circle. And so we said, okay, for it to be negative now, we said, hey, what quadrants is sine negative? What quadrants does inverse sine exist in? And we said, oh, the overlap there is quadrant 4, so it must be negative 30 degrees, which is in quadrant 4. Quick reminder in a picture is that, I don't know why I was trying to zoom, in a picture is that this would be negative 30 degrees is the angle right there. All right, on to the next one. If you have the inverse cosine of negative square root 3 over 2, we're really asking, hey, when is the cosine of what angle, y, theta, whatever, when is that negative square root 3 over 2? So we say, okay, well, when is cosine of an angle just square root 3 over 2 a positive one? And so we can find our reference angle for that. And our reference angle for this one is actually also going to be 30 degrees. And we must note that, hey, it must be between 0 and pi, aka 0 degrees, and 180 degrees for inverse cosine. And that comes from our previous page, once again, inverse cosine exists only in quadrants 1 and 2, where it's 0 to pi or 0 to 180 degrees. And we said, hey, it's going to be a negative square root 3 over 2. So where is cosine negative? Well, only in quadrants, quadrants 2 and 3. And if it only exists in quadrants 1 and 2, that must mean it's in quadrant 2. So we say, hey, where's the reference angle, 30 degrees? What does that pair with in quadrant 2? And that would be 150 degrees. Because 150 degrees, real quick on the graph again, on the coordinate plane, would be right there, 30 degrees from the x-axis over there. And 150 degrees in radian is the same thing as 5 pi over 6. Letter C, inverse tangent of 1. We're saying, hey, the tangent of some angle y, theta, whatever, is equal to 1. What's the angle going to be? And we must note that inverse tangent must be between just like inverse sine, negative pi over 2 and pi over 2, aka negative 90 degrees and 90 degrees. So we have to think, okay, inverse tangent. Tangent is sine over cosine. So when are sine and cosine the same value? Well, that's at 45 degrees and multiples of that. So like 45 degrees, 135 degrees, and so on and so forth. AKA the pi over 4s. Pi over 4, 3 pi over 4, 5 pi over 4, so on and so forth. And so we say, hey, the reference angle for this when sine and cosine are both square root 2 over 2 is going to be 45 degrees. And tangent is positive in quadrants. Well, let's go to our all students take classes. Tangent's positive in quadrants 1 and 3. And if inverse tangent only exists in quadrants 1 and 4, it must be quadrant 1. So we're actually just using 45 degrees, aka our reference angle. And in radian, it would be pi over 4. Inverse sine of 3. So we're saying, hey, sine of some angle y, theta, whatever, is equal to 3. And we remember that, hey, wait a second. We said a moment ago that sine is never greater than 1. And we said that right down here in these useful inequalities. And we also said it in the previous lesson, that, hey, sine and cosine only go from negative 1 to 1 each. So when we get a number like 3, we're like, that's not real. That can't happen. And so it does not exist. Bit of a trick question. All right. On example 2, use a calculator to evaluate the expression in both radians and degrees, round your answer to the nearest hundredth, and just switch the mode on your calculator between the two problems, or between when you have radian and degrees. On these, you're not given one or the other. We're going to find it in both. So we're supposed to find, hey, if the sine of some angle gave us 0.8, what angle was it? So how you switch the functions on those is you go to your calculator, and on whether we're using the in-class calculators or whether we're using Calc84, either way it's the mode button, which is located at the top of the calculator. And the mode button, there's an option in there for you to select between degree and radian. Ignore gradient for our purposes, and just pick which one you want, and then evaluate from there. So for example, if I type in inverse cosine, which is second sine, and right now I'm in degrees, and it reminds me if I have that little DG right underneath the screen on the calculator, and I put in, okay, 0.8 or 0.8, and it tells me, hey, that's 53.13 degrees, and it's to the nearest hundredth. And then if I switch the mode to radian, and now it says, hey, I'm in radian over here. I don't know why I did that on accident. And I do the same thing, so I just hit enter again, and it does the same problem, inverse sine of 0.8, but this time it gives me a completely different answer. It says, oh, actually, now in radian, that's 0.93 to the nearest hundredth. And so those are my two different answers, and it converted it for me. So it's 53.13 degrees, aka 0.93 radian. And I want you to go ahead and find letter B on your own, the inverse cosine of negative 0.473. So in degrees, this ends up being 118.23 degrees. In a radian, it's 2.06 radian. I already said radian, I guess, so that's a little redundant. All right, word problems. Woo! All right, great way to finish this one out. So an airplane rises vertically 2,000 feet over a horizontal distance of 2 miles. Okay, so we're saying, hey, it goes 2 miles this way horizontally, left to right, and it goes up 2,000 feet in that time. Left off 0. And that's going to create a right angle. Gotta love right angles. And we're asking, hey, what's the angle of elevation? Remember, angle of elevation is from a horizontal going up. Angle of depression would be from a horizontal going down. Angle of elevation of the airplane's path. So we're saying, hey, here's the airplane's path, and we want to know this angle right there. Now, it does thankfully give us the conversion from a mile to feet, because we're saying, hey, we have 2 miles, 2,000 feet, we would need the same unit. So 2 miles, well, if 1 mile is 5,280 feet, 2 miles, you double it, and you get 10,560 feet. So in order to find the angle of elevation here, we say, hey, from our theta, we have the opposite, we have the adjacent. So we would want to use tangent of theta, because tangent in our SOHCAHTOA, it's the TOA part, is opposite over adjacent. So you do tangent of theta is 2,000 over 10,560. Now, in order to solve this, we need to get theta by itself, or angle by itself. So it's not being multiplied by tangent, so we do not divide by tangent. That would be wrong. We are taking the tangent of it, just like when you take the square root of something, you don't divide by a square root to undo it. You have to undo it by squaring. So we have to undo tangent by doing inverse tangent, or you could call it arc tangent, as we talked about previously. They are the same thing. Inverse tangent and tangent undo each other, and now you're left with, hey, theta is equal to whatever the inverse tangent of 2,000 divided by 10,560 is. And the cool thing is, guess what? You can just type this into your calculator. And I'm going to ask for our answer in degrees here, but if you were to give me it in radian, I wouldn't count it wrong because I didn't specify. Now, if I specified, hey, I need your answer in degrees or radians, then I would take off a point or take off some points on that because you didn't follow the directions on that part. So this one in degrees would end up being 10.7 degrees, and I actually don't have the radian offhand. And that means, by the way, I want to explain this, that if you were to take the tangent of approximately 10.7 degrees, because we've rounded to get that, you would get approximately whatever 2,000 divided by 10,560 is. So I want to quick recap example 3 that, hey, it really helps to draw a picture there, okay? So it rises vertically up and down 2,000 feet, so we put that in vertically. Horizontal distance 2 miles, and we wrote angle of elevation. We had to remember or recall what that means for angle of elevation. Then from there, we selected our trig function by saying, hey, we have these sides, we want this angle. Okay, that's tangent then, because that has the opposite and adjacent. So whenever you're doing a trig function, whether it's the inverse or the regular one that we're going to end up using to solve, And you'd always want to say, hey, what two sides am I dealing with, whether you know them both or not, and what angle, and compared to my angle, what are they? Like opposite, adjacent, hypotenuse. Example 4. This one's going to be similar. It would be a good idea for you to try this one on your own. All right, 52 feet tall building. So I'm going to draw my building. Let's put a split door in the front, some windows. Make this look, at least somewhat decent. It's 52 feet tall. 52 feet tall. And it casts a 23-foot shadow. We want to know the angle of elevation to the sun. So if it's casting the shadow this way, that means the sun, let me find a yellow here, would be up here somewhere. The yellow doesn't show up as well as I had hoped. That's okay though. Worse things could happen. And the building would hopefully form a right angle with the ground. And we want to know angle of elevation. Well, the only angle of elevation we see here from a horizontal going up is right down there. So we want to know this, and I want to note that my picture got a little off. 52 feet is not the hypotenuse. It is the height of the building, like the prompt says. So once again, we have the opposite, and we have the adjacent. So we're going to be dealing with tangents. We say tangent of theta, because you always take sine, cosine, tangent of an angle, is equal to the ratio or fractions of those two sides. So it's 52 over 23. So we take the inverse tangent of both sides, and inverse tangent and tangent undo each other. And you could actually skip writing the step I'm writing right now, if you would like, by just typing inverse tangent of 52 over 23 into your calculator and going ahead and just going right to this next step of saying, hey, theta is approximately 66.1 degrees. So you could skip that step entirely if you would like. That's totally fine. Once again, I'm not sure what that is in radian offhand, though. All right, that is it for the note today in 8.4.